Perfect.
Hey, Paul, how are you?
Hey, how's everything?
Good.
How was your week with the project, guys?
It was okay. I'm actually the project lead.
Yeah, you told me about that. Yeah, has it been going on well? Like, did you guys start already?
Yeah, we made really good progress on our time because they were very adamant not meeting outside of classroom hours. So I've been very pushy about finishing things. But
Okay.
now the team there's 2 members on the team and they're doing their Matplotlibs graphs, and
Good.
they didn't finish on. But yesterday they didn't finish, so they're like, "Oh, we'll finish Monday," and I was like, no, let's try and finish Sunday
Deadlines.
night because I got to put the presentation. I have half the presentation together. I just need to add
Okay,
the
that's good.
Matplotlibs, add it, and
Okay. Yeah. So wait, are you guys given more time or is it already due?
it's due on Wednesday's our presentation, our actual presentation date, and
Oh, okay. Wow, that's pretty fast. So you're only given like a few, not a whole month, a whole month. Only like
no, we're just given like a few days. I think we started last week and then this
yeah.
week.
Okay.
And then my team, they're all like super shy. They're like, "Oh, I'm not comfortable with
Super
public
shy.
speaking." Yeah, and I'm like, "That's fine. I'll do the whole speech in 10 minutes. It's fine."
You guys don't have to talk. You guys don't have to all talk. Okay. I think it would be better if you guys all talk at least.
Well, yeah, that's what I thought, so everybody could put in their 2 cents, but like 3
Exactly.
out of the 5 were like, no, I don't want to. And I'm like, okay, that's fine. Then just
They
give
did
me,
some work at least. Whatever, it doesn't matter.
yeah. And I'm fine with it. I'm like, you just got to give me
Yeah,
notes so I know what your talking points are because I didn't do these graphs. So,
exactly. Yeah, that's good. I'm glad that you guys were able to get that done. So what was your topic? Is it
oh, it's so funny. Okay, so it's about food.
food? Okay. That's
This
good.
one, they chose food based on a survey from Mercyhurst University in Philadelphia.
Okay.
And we're trying to make a correlation of like if you exercise, you eat healthy. If your
Yeah.
parents were working parents, you tend to have you ate out more, or if your parents were stay-at-home parents and you
Yeah.
cooked more. So we're
Yeah.
trying to make those kind of correlations.
Mm, I see. Okay.
It's
That's
kind of like random,
it is
but
quite a I mean it's whatever. I mean as long as there's a data set and then there's
mhm,
some you have something to present, like there's some correlation between the data and they
yeah.
get significant wise. Like, oh, okay, this is my conclusion. That's as long. I mean, I think that's what I like about like statistics or like data science in essence, because like
Mhm.
you can say a lot about data. The one thing about it is what is your you have to be systematic. You have to
Mhm.
prove like okay. How did you get to the conclusion that you're saying? Because it could be relative. Like it's all based on the question that you're at. like your main goal, your objective, or why you want to why you want to like analyze that data. And then once you answer those different questions, then it doesn't matter. Like, and that's the thing about that data is you can make it. Sometimes it depends on like, do you have enough data, and then you can make enough conclusions from it. You gotta be like very I guess cognizant about what type of a data set you're gonna present. Were you guys given like the topic, or you had to choose it though?
We were able to choose the topic, and actually, it's funny. The 3 shy people.
Okay.
Were
They chose it.
They chose it, and they were very adamant about it. And I was like, okay, fine, not a problem if that's what you want.
But you should have at least, because like, what did you want to do?
I wanted to do crime because it seemed like everybody else was doing it, so I figured there would be enough data, and I just think there would have been a lot more data, but
yeah.
I mean, that's
what I'm saying. Like, I'm actually helping this other person too and then she's doing it in like, I think medical, something healthcare related.
Oh, okay.
And then like we were talking about what's a good what's a good topic, and I was like giving her some ideas, like, like in the end, it really doesn't matter like if you're gonna do obesity or like some heart disease or COVID-19, there's like so much data out there,
Yeah.
And then like it really depends on like the question you're trying to answer, like what are you trying to present to us, and then that main question is like you have to keep on repeating that, kind of like remind the audience, because she has to represent as well. It's a group, and then like, why is it significant? But for her though, she wants to do healthcare, but her other group mates want to do something about movies. It's like, and she's like, oh, I really don't want to do anything about movies because it's not something passionate. It's not something I'm passionate about. I was telling her, yeah, like for me, if I were to pick, and I was in her shoes, and I were to pick the data set, I would want a data that's that has a significance, that has some impact, like the result of it is something tractable right now.
Yeah, no, I totally agree, but they were just very pushy about it, and I was like, okay. And I've managed quite a few projects where it's just there's times to pick your battle, so I'm just like, all right,
yep.
all right, I'll give you your way, but we're gonna follow my timeline if that's what you want. And and it's been that way. But yeah, when I get my presentation done, I'll send it to you so you can see everything.
That'll be good. Like that's actually really nice. So after you guys have multiple chances of doing like projects throughout the year, or?
Yeah, so this is our first project. We have 3 projects we got to do. So this one is our first one.
Are they all Python related, or is it like this one's the first one, and then are you guys moving on to like Java?
No, our next one is SQL. We're moving on to. So we start that.
Oh, SQL, SQL, okay.
Yeah, SQL. I think it's SQL. And that starts on the 31st. And then our first assignment will be due, because we'll be back to homework. I think our first assignment's due Veterans Day, like the 11th, November 11th.
Okay.
So it's like, okay, so we had a nice little break with homework and totally project focused, which was nice, but it's just, I'm like, okay.
I like the part, when you're doing like I wish there would be more projects, honestly. But like I know why he's doing it, because like you gotta build the knowledge first, obviously, right? Like all the skills, and then finally you apply it. I'm just glad you guys get some project work, because like that's like the thing, if you're gonna, I guess, like apply for a data science field, they really, with anything, you always need something to prove, like not just you did some homework, good job,
And I'm like, me leading the project, I'm fine with that, because I can actually say I know how to lead a project, because I actually had experience in my old job anyways about it. And I was happy to lead this project and keep people on track, and then presenting the project, because my team doesn't want to, they want me to do it, so I was like, yeah, that's fine.
Okay. And is it always randomized, like so the next one it won't be the same people, or?
I don't think it's the same people. It seemed like it was a random group of people, because like there's 3 people who I actually never met or anything, and I kind of
class, right? There's like
there's like 60 people in the class. So there's 10 people, or 10 groups.
Okay.
And there's
oh, that's a lot of people so that's 6 people.
Yeah, our group had 6 people, but one guy actually never showed up. So I asked the professor and the TAs like, can I proceed without him? I've given him 2 days and he hasn't shown up to the breakout rooms. And so I got the permission to proceed without him because I was like, we're already assigning tasks. Like we need to move on here. We can't. I can't sit here and wait.
Yeah, that's fine. Yeah, I mean it's a lot of people already. That's like a big group. Yeah, you could definitely like I don't know how long the presentation is, but
10 minutes.
10 minutes. Okay. Yeah, like if you guys actually talk each one, yeah, that's like 2 minutes. That would be easy. That would be easy for like but if you have to do the whole thing.
Yeah, well one guy I told him he needs to because he's the one who cleaned up the data and he sent me all the screenshots. So I put it on a PowerPoint and I was like, well, you're gonna need to talk us through what you did in your thought process because I honestly don't understand your thought process. So so it looks like me and him are gonna tag team this presentation.
That's good. Yeah, I mean, I think what's great about it, if you are doing most of it, is then like besides like going over like all the different things you've learned, I think you'll get more out of it, like versus like everyone else that didn't do it, because then like you presented, it makes sense to you, and you'll be doing the same thing really. Like if you were to present it for like for another group in like the data science world, you'll be presenting every day maybe. So the more you learn like the process, the better prepared you'll be. So
yeah, and I'm totally fine with that and prepared for that. I'm like, I've been thrown to the wolves many times at my old position, so it's like you just
I'm glad that this is good because like once you do this and then I mean Python I think is a good one. And if you guys are gonna do this with Java, it might be harder. But definitely starting with Python, because it's just are you guys did you guys create like a notebook by chance like with all the results?
Yeah, so one guy created the notebook where he cleaned up the data.
Okay.
And then another person, so we're taking that data and then the Matplotlib people are going to create their charts and graphs off that notebook.
Okay.
So I think they're going to either merge it. I'm not sure, but Monday night we're supposed to talk about it if we're going to merge or not. So we'll see.
Okay. And then like the PowerPoint, is it on the notebook or is it on like a PowerPoint?
It's on an actual PowerPoint presentation, and then I have a lot of screenshots of different things that we did. Okay. So and then so I'll have the notebook on my GitHub, and then I'll have the PowerPoint so I can switch screens as I present. So
yeah, that's good. Yeah, sometimes that's what I like about like Jupyter Notebook really. Like I honestly I do all my like if I were to like talk about like the same thing as what you've been seeing, like all these different lessons and all whatnot. Like that's what I love about Jupyter because it's like live. You don't have it's like the one thing you don't like about when you're presenting something is when something doesn't work, right?
Yeah.
And so that's why when you create the notebooks, for me, if you're gonna do it, because like everyone does this with like Jupyter Notebook and with Python, is they create the notebook ahead of time, and then they have these guys, right? You have like the prompts here, and then like with this, you even have like the code already created with comments. So and then you just uncomment them. That's what I would do.
Okay.
Yeah, but if you guys need to, there's actually one of my colleagues actually you can actually create a slide out of these guys. Like like you have this notebook guy. And then on the side here, maybe I'll look at that and I'll show you next time. But on the side here, you can click on this, and then it will turn into a PowerPoint. Like it'll zoom out and into a PowerPoint for each one of these code blocks. It becomes a slide.
Yeah, you'll have to show me for the next project because I'll definitely like. Yeah.
Yeah, that's why Jupyter Notebook is like super streamlined. Like once I learned it, I was like, oh man, there's so much you can do because it's not just Python that you can run in here. You can run C++, maybe Java as well. There's but for the most part, it's just Python. The very first time I learned it was in Python. But the intricacies of like trying to create a PowerPoint and then like copying it because it doubles the work, right? Like what if you can just like write all your code, write the report, present from that report, and other people did like obviously if you just present it like this, maybe it's too small, like the font. So that's why if you have that slide like conversion, then it's already all in there. You don't have to really recreate the wheel from a PowerPoint to like a report or a report to a PowerPoint.
Oh.
Yeah,
Okay.
you can do that. I'll kind of show you if I figure it out. It's like right here. What ends up happening is each one of these guys becomes like
Its own
becomes a
slide.
PowerPoint. Yeah, and even, I think the code itself, since it's already here, like the result of it, some of this can also become a PowerPoint.
Oh,
And then if you have to come back and then like, okay, let me try to edit, you just revert. But yeah, it's pretty convenient. That's like one of those things. Okay. I forgot where. Do you remember where we left off?
We left off at start. No, hold on. Wait, what's today? The 25th. Our last time we talked was the 19th, right?
Yeah.
So we went over lock, and then we went to sort values.
Okay. Sort values. Okay. So we did group by sort values. I think. Was it lock or?
No, it was lock. We hadn't done group by yet.
Okay, so we did this string contains. So we did that one. We did. Okay, I remember talking about this, the mega one, with the lock.
Yeah.
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 Right?
Yes, we did.
Okay. I think what I'm trying to do is maybe let's just spend a few minutes of this guy just to finish it, and then
Okay.
like, I had this homework that I did like a long time ago. Because like one of those things, like you talk about the commands, yeah. But then the other thing is to like, can you answer like a question? And like there's a bunch of these questions, and it's kind of like create your code from it. And
okay.
And this one actually does Numpy as well. So we'll talk about Numpy and then kind of like Matplotlib. This is a weather data for kind of like what you guys did with JSON, but the oh yeah, did you guys do any JSON stuff?
Yeah, we did. That homework was awful. I haven't even submitted it yet because it's just.
Okay, no, like for the project, like, did you guys do any JSON?
Oh no. In fact, they said you can do an API, but it's optional, and I kind of persuaded my team to step away for that because I was like, we're doing it on homework already. Why do we need to include it on project? And
it's not some. For one, I don't really like doing JSON, honestly. If I can get away from it, because the thing is, like, you have the same capability with a Panda, like
yeah,
you just download it. The one thing is, it's just embedded in the website, like, and then the one thing I don't like is the API keys, honestly. Those API keys.
No, that API key is what's like, it was such a migraine, and I'm still
It is. Yeah, I got it to work, but but afterwards I did see yours. It's just the one thing, like if you find the website with the API key, you have to set it up, right? You have to set it up first. But then I guess for the Pandas, you don't have to set it up, so that's why I like that route better.
Yeah. No, and my team, it was 4-1 on the API key. So I was like, oh, well, majority rules. So we're not doing API keys. Moving on. So it's like.
You get extra credit if you do something like both? I don't know.
No, it said it was optional.
Okay.
And I felt because I really didn't care for that particular subject, to be honest.
Yep. Yeah.
I felt because it was optional, I was like, well, we don't really need to do it. And we're already doing the assignment this week anyway. So.
Okay. Yeah, it's if you're still in doing it, yeah, API, I try to get away from it. You don't need it as much.
Okay, so you won't need it in the real world, like.
Yeah, like in terms of know what you need, like after this class, it's really just Pandas and then like how to plot it. That's why those two skills, learning how to edit your data frame as well as like visualizing it. Besides Matplotlib, you might also want to learn like maybe Seaborn. Seaborn is way better than Matplotlib.
And it's, how do you spell Seaborn?
C like the ocean, and then born as in BORN.
Oh, okay.
Yeah, it's a weird name. Maybe it's a person's name.
Yeah.
So what is that? So like Seaborn, what it does, I'll show it to you a little bit. It's in this weather thing. It's based off Matplotlib, but it's just easier to work with Pandas with Seaborn versus Matplotlib. Like there's just some and then the way you have like how they have it coded and how you input different things and use the functions they have, it's more streamlined, easier to understand than Matplotlib. Either way, they give you the same capabilities, but there's just more flexibility with Seaborn. Okay. So that's why you end up using it more. Okay. All right. So I guess we'll kind of breeze through this because like you guys already worked on a lot of this, yeah.
Yeah, but I mean, It's
okay. Do you remember? Let's just talk about this one then. So when we did like lock, that's what you usually do if you just have strings, right? You want to work with strings.
and you have to know the column names by name.
Yeah, if you do iLock, it's a number thing.
It's like it's the number column.
Hence the I index lock.
Yeah.
Yeah, and if you like, for example, this one, you can actually for the other ones we use lock just to filter it, but here you can use lock as well to edit different like column and row names. So like for example, what if you wanted to change like for this first one right here? What if you wanted to change this grass name for the type 1 to grass or whatever you want, right? You can come here and just like say, okay, I want to filter my data frame, and then I want only the to change the type 1 grass to grasser. So in order to do that, you need to put it inside this bracket and say equal grass for the columns right here, and then for the type 1, this is where you're gonna have where we're gonna look for that grass one, right? And then whatever you put here to equal it is gonna change this guy.
Okay, so you don't have to do the, okay, this is changing the data inside the rows. Okay, never mind. Yeah. I was thinking like the columns, it had to be the curly brackets. Okay, but never mind. That's a dictionary. Never mind.
And then like, what if, instead of like a string, you wanted to change the Boolean? Like if there's like a Boolean, it's the same thing. The one thing, whatever you put on the right here, like, this guy is type 1, right? This one goes in there. This is where you're going to change it. So this one, it changed the type 1, wherever this grass is to grasser. And now since we have grasser, right? Wherever you have grasser, which is right here, you look at the legendary.
You wanted to say true.
Okay. Yeah, you want to put true there, even though it's not true. So it's like manually, like you wanting to edit something for a particular, that meets a particular category here. So some of these, you're gonna have to go back and like, oh, when am I gonna use this? Like, and I think what's because I gave you some of these, and for me, like if I were to like like use this again, and then like maybe now I don't see like the capability of it, you can always just Google it. Okay. Like there's only some things that you can retain, right? Like with code, and then I think the more you use it, the better. It's like, okay, now I know why how to apply it. But right now it's just like, okay, that's the capability of it. Like, and there might be no like significance now, but later on. Okay. Another thing is, what if all this is just grouped by an aggregate? Yeah,
that's where I was very confused.
Okay. So for group by, if you wanted to sort using group by that mean, so for example, this guy, so all you have to do is whatever you put in here, this is what you're going to group it by. Like when you say group by and whatever inside this bracket, all these guys will become your index. That's what group by does. It changes the index and it groups them by that guy.
Okay, so group by.
So what if I did this guy right here? So like, what if I did type 2, right, instead of type 1? It's gonna change this guy. So now they're all grouped by type 2. Or if you wanted to do like HP, so all of them are grouped by HP now. Okay. So whatever you put in here, it's something like, for example, if someone were to ask you like, oh, I want to group and sort the type 1s or like the highest HP, or the whatever it may be, then you can always do the data frame group by and whatever that column name may be. And then, for example, with this one, I did .mean because I wanted to group them by mean, like the mean of it. Yeah. Which is like right here. But if you just wanted to group them by maybe like HP, you could just do sort values, and put in whatever you're going to sort by the criteria.
And that would be the HP.
Or defense, whatever it may be. So right now, if it's like, for example, this guy, right? And I think we talked about this ascending one.
Yes, ascending is false, descending is true.
Yeah. And so as you can see, you can confirm that it's obviously descending. And yeah, that's really what it is. For the most part, group by is very common. Like when you use it, you use it along with like sorting things, with summary statistics. and it's easy to read your data, manipulate it using that, and get some insight. And then another one, you could also use some. We'll skip that. It's kind of similar. But this one right here is, what if you wanted to ask yourself, like, how many different types of things do I have in my data? That's a pretty common one. Like, you can count like how many, for this one in particular, yeah, how many bug types do you have? How many dark types do you have? You can just flag it. You have to create a flag though. Like, so what I mean by that is like this df.count equals 1. Is so if you have that count as true, you're gonna put 1 in there. So, and then what ends up happening is, like, once it counts it as like this guy, so it's gonna count each one of these, whatever is in type 1, all the categories in there. It's gonna add like a 1.
Oh, this is like almost like for looping.
Yeah, in a sense, but like we don't want to. Yeah, I think the way they do this, it is in fact a for loop. Like, it will check each one. It's like, oh, is that a bug? Is that a dark? And then after I do that, I add to it. Like, oh, I'll add 1 to bug if I check each of the rows. Like, oh, is that a bug? I'll add 1 until you get 69. And then I'll check again the dark. Oh, is it a dark? And then until you get 31. And all the other ones are like, So it's like counting. You just count each one.
Okay.
And it, and I guess this would be an easier case. Like, there's another way of doing it. Maybe just without using a flag. But I think that this one works. If you were to do this with another, project, now you can do it.
Okay. And what's the purpose of the flag?
The purpose of the flag is so that you can count it. Like, you can add 1 to it. Yeah.
Okay.
Because then if you count each one of these, it will just not add in 1 for each one. So.
Okay, gotcha.
And then you've seen the correlation. Like, when you do this, you've probably seen this before. Let me show it first. So, like, for example, like, you have a bunch of like categories, right? And then like you want to see the correlation between 2 categorical variables. You could just do .core, and this gives you like, is it positive? Is it negative? Right? Do you know what a correlation is?
Not really.
Okay. So a correlation. So for example, I guess I'll explain this part first. Because like, we're actually gonna make this look better, because there's what we call like a heat map. And a heat map is just a visualization of this. It'll use like Matplotlib to like create different like colors depending on if it's like highly correlated or like low correlation. But if you look over here, for example, you look at HP here, right? And this is HP here. And when you technically read this like an X and Y graph, so you line them up.
Yeah. Okay.
So if you line HP with HP, obviously it's the same thing. It's gonna be exactly the same. So it's 1. Whatever HP the number is gonna be the same if it's 1, right?
Yeah.
But if you line HP with attack is less than HP. That's what it's saying. It's less than 1. So attack is like 40% of HP.
Okay.
And then like defense is like maybe 20% of HP. And so on and so forth. Like, it's kind of just like kind of like a fractional relationship between like their magnitudes. Like when which one is bigger. For now, like, maybe these variables doesn't matter. I think maybe if you look at like maybe attack and defense, if you have like a high attack, but then the other guy, the defense for most of these, most of the the Pokemon that you have, the defense is 40% versus their attack. Does that kind of make sense? Or it's like a correlation between 2 variables. This is like a statistical thing. Like when you're trying to correlate like one data type that's categorical from another data type, then you can see which one is higher, which one is not.
Okay, I can't see which.
And I think it's like mean and then like standard deviation. This is just another metric, statistical metric, to like, if someone were to ask you, I want to know the summary statistics of my data set, data frame. And then one of those guys that you probably will have to print is like, oh, I want to know the correlation. And usually a correlation, you can see this better if you've seen a scatter plot, right? So you know the slope of the scatter plot, like, it's like kind of like just a line, like a linear.
Yeah, I don't really understand that part.
Okay, so if you remember, we'll talk about it once we look at like Matplotlib.
Okay.
If these guys are like positive, that means your line is linearly increasing, right?
Mm-hmm.
If these guys are negative, it's linearly decreasing.
It's gonna go down. Yeah.
And if it's 1, there is no increase. It's just flat.
Flat. Mm-hmm.
Yeah, and that's what this tells you the correlation, or in other words, it tells you the slope of that line. It tells you the slope of that line, the linear regression line. And then like, depending if it's like a positive regression, that means like, oh, if this is relatively increasing, this is the effect of another variable. And if they're negatively increasing, that's like what you plot. And after you plot it, that's like what you conclude. Like after I look at this scatter plot and this correlation map, I can conclude that maybe the attack is positively correlated with the defense. Or like in this case, there's a negative one. Like maybe,
so
yeah, like
it's going down.
Yeah, so this one's going down, so it's negatively correlated. So for each generation, maybe the speed goes down, something like that. You can say something like that. And that's just that's like the end goal. It's like, oh, I want to see some pattern in my data. Like, is there one? If there isn't one, obviously they're all going to be like 1, and most of these are not.
So we're really looking with the correlation. We're just trying to see if there's pattern in the data.
Yeah, it's one thing. There's a bunch of things. There's you can either graph. This is like this is one you would do if you have like a bunch of categorical variables, like this guy. And then like this is usually this is very relative to like or related to the scatter plot. They show pretty much the same thing. If you show like a bar graph or a line graph, I think that this has no correlation. That's another thing. Like you can show a line graph, it'll give you some set of conclusions, and then you can show a bar graph to tell you like how the relative like sizes of each category. Okay. And then like, do you remember we talked about functions? Like you can create your own functions.
Yeah.
Okay. If so for example with data frames, we use all these functions, group by, we have like describe, we have correlation.
And the dot describe, it goes mean, median, mode, standard deviation. It gives you all those details, right?
Yeah, let's actually take a look at it. Yeah, that's the one. Okay. It gives you like all these good, that's a count, mean, standard, yeah.
Okay.
And this is one that's very nice, like for one, like if you wanted to show like maybe like to someone this is one that to really, it's an easy one. You just create your data frame and you do that describe, right? Mm-hmm. So another way maybe to visualize, like this better, like this min 25, 50, 75, and max, is maybe you can show like a box plot, like box and whisker.
Oh, okay. Yeah, I think I know what that is.
Yeah, the box and whisker is a good visualization of the quartiles, from 0 to like max, min to max, and all these different ones. And then like for this mean and standard deviation, you can show either a histogram. There's always a counterpart. Like for each one of these like different statistical numbers, there's always a visualization tool to better show them or display them so that you can query if there's a pattern. But you always start out with this. You always want to see what the numbers are, and then like, okay, now I see it. I want to show this to someone, so let me visualize it. Okay. So like for example, for this one, like what if you wanted to do, this is for a movies one, or not a movie, like for me looking at this, like if I were to rate it, I would probably think of a movie. But for this one, if you wanted to like create your own function like that does a rating, you could just do this, where like maybe you wanted to ask the questions like what does a good attribute mean, and what does a bad attribute mean? So like, do you remember though, like how to create a function? I can explain it again.
Yeah, can you explain it again? Because I'm
okay.
This what's upsetting is like some things are sticking and some things are not, and it's
okay. No worries. Yeah, because we only talked about it once. That's why I wanted to like talk about it multiple times. And the reason why I put this here is so that because we talked about it, and I want you to see how it's applied now to like maybe data science. So one way you can apply a function creation with data frames is here. So when you create a function, you always do DEF for definition. And then the next thing you put in blue here is the name of the function. So this is the name of the function. So this can be anything. It's up to you. And whatever I put inside the parentheses here, this has to be general, because when I say attribute, it's gonna be any of these guys, any of these labels that I'm gonna pass it.
Okay.
So whenever I define like a function, I always want to keep it general, because I want it to take in different values, different labels. So this attribute is gonna take in all these different labels, and you're gonna see it. So for example, now this is general label. So if the label or the column name is greater than 50, then you return good.
Okay.
This is the rating, right?
Yeah.
So this is the function of this function, or like the reason why we're creating this function is we want to rate each one of these guys. Okay. And then, so if it's greater than or equal to 50, it's good. If it's less than 50, that means it's bad.
Okay, so this is almost like a for loop again too, or a while loop.
Yeah, it's like a while loop. Yeah.
Okay.
Going back, yeah, that's good that you're seeing that relation. Yeah, all of this, they're supposed to be related. The way you create them, they're very much so related. It's just the way, like, oh, okay, that's how you, yeah. So like once you do this, and then it's pretty much defined already. This is your function. Like you're done, because you're already returning good and bad. So let's try to use it. Like I'll just explain it first how you would do it. So the reason why I wanted to do this is I wanted to create a new column.
Okay.
This is the column I want to create, this guy. So what I want the column to take in is so this DFHP, this is the column, this guy, right?
Yeah, that's what we're looking, if it's good or bad, is from that column.
Yeah. And then so what I want to do is I want to apply this rating function to HP. And then this is just how you do it. So after you define this guy, this rating function, I want to do DFHP dot apply, and then I put the rating function inside. So in plain English, I guess this means I want to rate the HP column. And then I want to put that inside the ratings column.
Yeah.
So like the attribute now, this attribute guy is going to be HP. That's the attribute. So
okay, that's the column you're calling out.
Yeah. So for each one of these rows, these observations, these rows, I'm gonna put that inside here, and I'm gonna check if each row it has a greater than or equal to 50, and if each row's entry is greater or equal to 50, it's gonna be good. Like this guy right here.
Yeah, that's good.
Yeah. This guy isn't, so it's bad.
It's bad.
Yeah. So that's it. I mean, this is a simple one. It's meant to be simple, but you can make it complicated.
No. No, lean. We're thinking lean.
Okay. No, like what I mean is like in terms of like application, like, I don't know if this can be applied or produced.
Oh, okay.
I mean, if it's good, yeah. What does good mean?
Yeah. What does good look like?
Yeah. But that's how you do it. It could be any other like rating. You can make it like, okay, this is 5-star, 3, whatever you want. Another one, I guess this is another way to create like a function. And I guess here, what I'm trying to do is just to show you like to do it another way. Like this is a longer way, right? There's more lines. Here, it's only one line actually.
No.
Yeah, all of that, like all this right here, all this guy can be done in one line.
One line.
But this is called an anonymous function. So this one is called the defined function, because we called it a name, right? A specific name function. Here we don't have a name for it. There's no name. As you can see, this part is the same as this guy, yeah, as this guy, right?
Yeah.
Up to here is the same.
Yeah, and then in the parentheses, it's where it changes.
It changes, but essentially this whole thing is doing what I did here.
Okay, I like line 16 better.
Yeah, it's just like it's usually in code, like the more concise it is, the more, I guess, like the lean is always good in code, but there's more work, like
yeah,
in the back end. There's more work in the back end. But here, like, okay, I see what you're doing. Here, one-liners seems like I get it, but I have to think about it.
Mm-hmm.
But how you do it is I mean, you just have to know like the syntax. That's what it is. Like everything, like like an expert person, it's just because he's seen so many of these. He's Googled so many things.
Yeah. So and with coding, there's a lot of Googling.
Yeah, there's a lot, and it's just really what it is like making it your language. Like okay, so and you know how to relate. Like okay, I've seen this before. Let me apply it to my scenario.
Mm-hmm.
So anyways, like for this one, how you do an anonymous function is you have to put it in this lambda. It's kind of in comparison or like it's the same as doing def.
Mm-hmm.
Instead of using def, you use lambda.
Okay.
And then lambda, this is just called an anonymous function. You just have to do lambda. And then what you put in here is what you had to put inside the parentheses here. So this is the one that's going to take an HP.
Okay, so that's the attribute.
Yeah, so this guy right here. And then what you put here is you have to put in like, there's just more things. That's, obviously you're going to put in like a colon. And then after you put in what you put is like what you would return.
Mm-hmm.
And then you're going to say, I want to return good if the attribute is greater than or equal to 50. It's not that bad, right? Like if you look at it, it's not that bad. And then else, it's bad. It's the same thing in essence.
Yeah.
Yeah. So, pick your game. If you like this, seems like it's easy to do this. If you like this, for me, I actually like this better.
Oh, okay.
The reason why is I'm used to creating these def functions. This lambda one, I mean, it's like something you have to just get used to.
Mm-hmm.
It's faster. It's less writing. So.
But yeah, it's just you have to know what you're doing on it.
Yeah, and the more you do it, it's like okay, now like once you find the relationship between these two and kind of like go okay, in certain situations I like this. Maybe this one fits more of what I do, so I'll do this. But just learning like when to use them, when not to use them. Okay. So for this next part, I think I was thinking like this is kind of like an abridged version. Let's just move on to because of like the Matplotlib. So let's just take a look at maybe with this kind of like the Numpy and Pandas, kind of like answering some how you would apply them, like if there's a scenario. Let's take a look at this. I didn't actually give this one to you, but I'll give these ones, and after today. So what we have here is part one. I think there's like 3 parts. Part one, we're going to be working with Titanic. This is a pretty common one, a Titanic database. And I think for these ones, we're just going to count like, the number of like people depending on if there's different categories that they meet. So we're going to be talking about like how to filter them, unique things, and how to sort things, which is something you already know. And then like different ages, do some statistics. So let's see. Let me I guess the best way, because we've already talked about it. I think what may be good is if I ask you, and then maybe you can tell me how you would do it.
Yeah.
Okay.
Yeah, I'll do my best. Yeah.
Because I think it'd be better than just.
Yeah, no, it's fine.
Okay. So for this one, so after all the boilerplate stuff, like the reading the database, transferring it over to Python. How can you print the first 10 entries in the data frame?
So you get your CSV file name, whatever you call the file, the passengers.
Okay.
And then you do the dot head, and then inside the parentheses you do 10 because that's how many of the rows you want to call out.
Okay, that's good. Yeah.
And then normally if you do dot head and you leave it blank, it would call out the first 5.
Good. Yeah, that's actually the one thing I want, like knowing like when it changes. Okay. What about this next one? So for this one, print the 10 elements again, but indexed it by passenger ID.
Okay, so next set the index.
Kind of like what I did here. I'm just gonna try hide what we did.
Yeah. So it'd be your file name, passengers, and then equal, and then you do the bracket.
Okay.
The passenger ID.
Okay, I think that sounds good. So like passengers, and then you do this thing, right?
Oh, so you didn't do equal?
I didn't do equal because all you have to do was do this guy. I just wanted this guy in there. First 10 entries of the passenger ID.
Oh, okay.
Yeah.
Okay, so it's just a square. It's passenger square bracket, quotations, passenger ID, and then and you print out however many you want it to call out on the data frame. Okay.
And then for this one, how many samples are there in the data set? How would you do
that? Passengers dot count.
Okay.
Parentheses.
Passengers that count, and let me see. You could also do that. Is that count like this?
Mm-hmm. Oh, it's giving me each. Yeah, that's giving me all of them. Okay, so then this one we wanted.
I think for this one, yeah,
passenger ID. So then we need to do a square bracket, passenger ID, and then dot count. Okay, and it gives me the final count. Okay.
Yep. Yeah, it's the same thing. And then the reason why I did shape here is so like shape gives you this guy, right? I think if I remember, it gives you both the sides of it.
Mm-hmm.
So like the first one gives you the number of rows, and then the next one is number of columns. So you can just do this by slicing.
Okay. That's how you slice it. Okay.
Yeah. Then this one is the number of passengers in a different class. So how would you do this? What is the number of passengers in different classes according to this data set? So let me just see. What is the number of passages in different classes according to this data set? Number of passengers in different classes. Classes mean like, he's talking about this guy right here. Like in
okay,
first class,
P class.
Titanic.
Okay. Yeah.
So like, how can you know, or how do you enumerate the number of passengers in each class?
Passengers equals square bracket passenger ID, and then you would do a comma for passenger class. No, P class.
Okay.
And then would you do a dot count? No.
It's kind of like this. Okay.
Dot count. Yeah, a dot count because you would oh no. Oh, okay.
So for this one, okay, let me just see. You do group by, yeah. Do you remember that group by?
Oh, okay.
Because then like you want to change your index, right?
Okay, yeah. So group by, I want to change my index. So I want to go, my P class is going to be on the left side. And it's going to have P class 1, and then it'll tell me how many passengers, passenger ID in the column. Okay, so we want to do group by on that one.
The reason why you want to do group by is so just looking at the question, like what is the number of passengers in different classes according to this data set? It's wanting you to do a group by because it's saying what is the in different classes. It says the number of passengers in different classes. So I guess the population, the thing you want to group by, is the class, right?
Mm-hmm.
If they said like the number of passengers that survive,
or then like survived would be the index
for each like gender, for each age, whatever you want to group it. Like once you're asking a question, like number of this guy within this population, it's what you have. That's the time when you use a group by.
Okay, and the P class. Okay.
It's the population you're gonna group it by, or like whatever the column that you're gonna group it by. Because in this case, passenger ID is just the count. It gives you like the count. That's why, the different unique IDs for each individual passenger. And then like once you count that because it's unique for each one, you can just do like, this very first part right here. This filters it, right? This very first part filters it.
Yeah.
And once you do the group by P class, you're gonna move things around, and then put the P class as the index. And then once you do that, you usually don't just group by. You usually group by and then you do something, right?
Yeah, the dot count.
That count, dot mean, dot sum, whatever. So dot count, for each of these, whatever your population is here, you count them for each passenger. Okay. Yeah. And I think much of the group by, learning how to do group by, you just have to experiment with it. But this is the time, and for the most part, you're going to be using group by a lot of times.
Yeah.
So just knowing like the kinks, like, where do I place it? When do I use it? What do I put at the end of it? This is the time that you would use it.
Okay.
Okay. What about this one? This one's a little bit different. Let's try it. How many different fares were charged on the Titanic based on the data set? How would you do that one? Fares, let's look at the data again. So fares would be this guy right here.
Okay.
Like, there's a bunch of them, and I want to know. Some of them are, obviously not everyone paid. Like, there's a lot of people. Not everyone paid a different fare. So I just want to know the unique number or the unique types of fares.
So it'd be passengers, square bracket fares dot unique, and then parenthesis.
Kind of like this. This next one's actually going to show that, which is a little bit longer. So let's just take a look at it. So it's that unique, and then you have to count them, right?
Oh, okay. So I have to do the length. Okay.
Yeah. So you have to count them. So what ends up happening is that, let's just take a look at it. This is the one that you said, right? That unique.
Mm-hmm.
So let's take a look at that unique. What does it give you?
Oh, it gives you a list. Okay.
It gives you a list.
An array.
Which is pretty much everything that's unique. And then and how do you count how many is in a list? You do len, right?
Yeah, len.
Yeah, you len or something. You could do dot count as well. So len.
And that gives, and it's 248 unique fares.
Yeah.
Got
really
it.
Like this dot unique one, I think it's good. And then there's always a combo here. The one thing I want you to know is like what type of data is the result of like dot unique? Is it a list? Is it a row? It's a list, right?
It's a list.
Or yeah, I want you to. I mean, in essence, you don't have to memorize it, but like just kind of like get a gauge of like, okay, this gives me a list, and then if it's a list, what I can do is I have to apply len. It makes sense once you know it's a list, you know that you have to apply len, right?
Okay, so if it's a list, len is applied. Okay.
Yeah, because that's going back to what we did with collections, like all those different things, like slicing a list, and then like finding the number of elements in the list. If it was like a data frame, then you do dot count, right? Because then it'll count the number of rows. You won't do a len for a data frame. You have to do a dot count. Or the one thing I said, the shape 0. All right. So what about for this one? Find the top 10 fares charged from the passengers. So like I guess when I say top 10, that means like frequency. Like what's the one that has the most? Than the top 10. The top 10 that has the most. That's passengers that got charged. So I'll show you. This is a different kind of hard. This is like probably the harder one. But this is supposed to be the result.
Okay.
So like for example, if you look at this is a frequency, right? This is
the okay. So that it was 43 times was charged for $8.05.
Exactly, and then like so these are the top 10, and it goes down.
Gotcha. Okay.
And that's the answer to it. But let's just take a look at how you would do that one. This is a little bit difficult. So when you do, it's kind of like going off what we did with the group by. We did the group by with the P class. Try to see if you can find that relationship. So like if you take a look at this, why are you doing group by? Like for this one.
We're doing the group by because we want to see the fare is going to be the index.
Fare is going to be the index, and then we want to count. What if you? We want to count them, right?
Yeah, we want to count how many times like the $8.05 was charged.
Kind of like this. That's how you find the frequency.
Mm-hmm.
So group by count, it counts it for each one. So that's how you do a frequency. And then how come we're doing dot sort?
Because we want to see how many times it was charged, but we want to, and it's an ascending order because we want to see which one had the most charge, which fare had the most charges.
Okay, yeah. So like how I would do this is like probably first like break it down. Like if you were to do this from scratch, it's like how do I give them the top 10? I'll probably do so. I know it's gonna be grouped in fares because that's the population. So you'll probably do this. It's like how do I give them the number of passengers? I'll do dot count. So okay, you got something, but they're not sorted out. And then you just kind of like fit the blocks together. It's like and then print it. So it looks like this is the one. So that's it. Like a lot of this is just doing it. And if it was bottom 10, what would you do? If it was bottom
hot 10? Tail.
Okay, good. Yeah. All right, let's look at this next one. So create a new data frame. Include passengers filter that includes only entries of passengers who paid one of these top 10 fares. Report the number of samples in the original data set and a new data set to ensure that the desired effect took place. Okay, so I know this one is a little complicated. What I did here is like I had to filter it out. The ones that who paid the one of these top 10.
Uh-huh.
So that's let me see how many of it. So because he wants me to do the color that includes only entry. So the new one is the only it's only the passengers who paid one of these 10 guys, right?
Yes.
And then the old one is the 891. The old one right here. The original
Yes.
one.
Okay. So our data frame is going to be a lot smaller after we filter
because it's
everything
only
out.
these guys. Yeah. So that's what I did here is so I filtered it. How you would filter it?
Oh, I see what you did on the printing out the original list. The length of the passengers is 891, and then you print the length of the
that's
passengers.
what they wanted us to do for this one. It's just to compare. It's like, oh, did something happen? Did you do it correctly? But how you would filter it is this though, which is a little like what the heck is this ISIN?
Yeah, ISIN.
So I think I remember I had to Google this one. So what this ended up doing is ISIN. It's gonna take what you have here. Like this right here is what we did before, right?
That's what we did up there. Yeah.
Yeah. Exactly. So after you do that, it's up to this guy.
Yeah.
So it's inside the ISIN. That's what inside the ISIN. And then, so if that's what you want, all you have to do is apply it to the fair column, and then it's gonna filter it. That's what it does. So like once you what you put inside the argument of ISIN, and you apply it to the column, it's gonna filter it. And once you filter it, all I want is the top 10. And then like the dot index to list. I think I remember this one. This one, you gotta manufacture it. It's like one of those things that you gotta just like, what type of It's like a rare occasion. You don't really need to do something like this if you in an everyday basis. So index then to list. This to listing, it creates a list out of what I just did. So in essence, like just to make it simple, what I did is you use ISIN. Whatever you put inside is what you're trying to filter, and then like when you're trying to only it's your criteria, right? You only want to get the people with these 10 fares. So you put it inside there, and then you apply it by doing .ISIN to the one that you want to filter. That's it. That's what I did here. And then once you do all of that, it's gonna break down the 891 to 276. I think there's an easier way of doing it, but I felt I didn't want to do it that way.
That's fine. I mean, eventually when you're coding, you do what's more comfortable for you, as long as you get the same.
It's probably at that time it's what I saw like worked.
Okay, gotcha.
It's usually that is like what works in that sense, and if there's an easier way, maybe because I remember I was talking like, don't try to use like different functions. Try to like go back to the basics of what we did here. Like use group by, use .count, and then try like, okay, can I make can I filter a data frame with just the basics without using like ISIN or another function? Because it's like a black box. What does ISIN do, But anyways, yeah, that's what we did. And then this next one, you probably already know. This is an easy one. What's the minimum and maximum and average age of passengers on the Titanic? That's an easy one, right?
Yeah, you just .min for the minimum age, .max for the maximum age, and
exactly
the average age .mean because that'll.
Yeah. So that's not. I think that's like a preliminary thing. So the next thing is how many passengers on the Titanic were within 2 standard deviations of the mean. Do you know how to do that?
No. Okay, and I struggled with this in math class in college too.
Okay. So like when they say like, let me see. So when it says 2 standard deviations, like on it say of the mean, it's just like plus or minus. Like when they say of the mean, like you have a mean, right?
Yeah.
You have this guy right here. This is the mean.
Yeah, 29.
And then like if you remember the let me just draw something here. Do you remember seeing something like this in like before? Something like that?
Yes.
And then you have this guy, right? And then like from here, I'm pretty bad at drawing, but like this.
No, but I recall this chart very vividly.
Okay, it's not that bad. That's like it's just something that you have to like like you add this guy, right? This is the sigma, right?
Uh-huh.
And the sigma is what? Do you remember?
No.
So the sigma is the standard deviation. So if it looks like a sigma, so and this other guy is the minus, right? Because it's going to the left.
Oh, okay, yeah.
And then so that's what it's wanting you to do. It wants you to do like from this guy all the way to this guy.
Okay.
Like from -2 standard deviations to +2 standard deviations of the mean.
Okay. Okay, so it's like a range within the mean.
Yeah, and that's what you have to do. So since you kind of know that, it's like mean -2 sigma, 2 standard deviation, and then mean +2 standard deviation. Let's try to see if we can code it. So how you do that is, let me just see how I do it here. Okay, so this first thing, line 2, is just printing how many there are in there that are within this 2 standard deviation. This is what it's asking, how many there are. And then this number 3 is just printing those guys that fit this criteria.
Okay.
So how you can like filter it, by, okay, I want to only get the passengers that fit this 2 standard deviation of the mean, is you just do the equation. You create an equation, like let me see. It's just this, right? Like you have mean plus this guy, right?
Mm-hmm.
Or like mean minus this
guy.
Minus
2, yeah.
Mm-hmm. So with that, like that's what I did here is like what I coded here is so you have to do iloc. iloc, is what you do, and then you have different criterias for iloc. The first criteria is like, let me see where it ends. So you have this guy all the way here. This is the first criteria. This guy. So let's try to parse it out. So I want the passengers with an age that are greater than passengers with age dot mean. So the mean of the passengers minus 2 times the standard deviation, right? This one makes sense now, right? It's kind of like the equation, isn't it?
Yeah, it's the equation typed out in the code. I think I'm following. Okay.
But like obviously the reason why we're doing, and that's why like when you see this, like, oh, this is what it is, because like this is how you kind of access the columns and then their means and then their standard deviations, right?
Yeah.
This is how you access them. And then so the next, after the ampersand, the next thing is just the other equation, right?
Okay, and this is okay. That was like -2. Now this is +2.
Yeah, and then the one thing here I forgot to mention is it's a range. So you do greater than and then equal to and then less than and equal to.
Oh, okay.
Because it's a range, right? Like it's like in between. Like I want the in between. So that's what you have to do. You put in the equation. You put in the this comparison so that you can filter only the ones that fit the range, and you put it inside an iloc. And once you put it inside an iloc, it's going to filter it, right, to fit the criteria.
Okay.
Does that make sense?
Yeah, but you're saying iloc, but it's just the.
Oh, no, not iloc, the lock.
Okay, I was like, it's saying lock and iloc. You're not calling out the index. Yeah, you're not calling out the index number. You're calling out the name, the label.
I never, for the most part, I never use iloc. It's usually
okay.
Lock is the one that your best friend. No one ever uses iloc.
Okay.
Okay, so this one is one of the first ones that you got to do this. Like I think a bunch of these questions want you to do some filtering. So let's take a look at this. Yeah. So this next question: how many of the passengers found in the previous were females over the age of 25? So it's just gonna build on itself, which I think is bad because what if you made a mistake here?
Yeah. Oh gosh.
I hate those types of exams. Like, oh snap! Like what if it's like part A, B, and C? So how many of the passengers found in 5.2 were female? So this is gonna get like longer. So you understand the first one, right?
Yeah.
Now you have to use that and then make it longer.
Oh my gosh.
And the other way, I didn't want to do it this way because the other way would be put all this inside a variable. Yeah, you could do that, right? You could put this inside a different data frame variable and then work on this guy. So what I end up doing here is using the data frame we did up top, let's just, how would you do this though? How would you filter out a data frame, for example, this data frame, where the females are over the age of 25? This is an easy one, right?
Yeah, you would do the greater than or equal to 25. You would need to type that out on the age in the square bracket.
This
Oh
thing,
no.
right?
Oh no. Oh wait, you need to include the sex too, because you need to know what gender.
Yeah, yep. It's both of them. It's both of them.
Okay.
So there's two, like there's two things. You always, when you're reading stuff like this, like you're always wanting to see what are your criteria that you have to implement in lock. Like, okay, I want to implement the gender as well
the
as
gender.
right? If there's more, then it just adds up. That's why it's easy for lock, because you can take in as much as you want, like as much criteria that you want to put in there. It doesn't matter how many, but you know, you just need to know like how to put them. For example, for this females one, it's just passenger sex equal female. So that's it. And then the next criteria is age 25. Passengers age greater than 25. That's it, right?
Okay.
And then the reason why I did this last part is just the same thing as counting it. I wanted to count the column, right?
Okay.
I wanted to count the column for age.
How many in the age? How many are over the age of 25?
You could have just done as easily as like say dot count parentheses. It's the same thing.
Okay.
But yeah, like it's not bad, right? Like this is just practicing how to do locks.
Yeah.
And then, like,
yeah.
Let me see the other one. Oh, okay. So this one's kind of like what we did with the fair. Let's try see if we can. I mean, it's exactly the same, honestly. What are the 10 most common ages of passengers according to this data set? It's exactly the same, right?
Yeah, instead of fair, you would put age.
Yeah, that's it. And I think seeing this now, it's like, and then you might see like another one. It's like, oh, I wanna. You can actually graph this. You can graph this into like a frequency, or maybe a histogram, something like that. And for each one, it's a category like 1, 2, 3. Or for passenger ID. And so yeah, that's it. That's an easy one. Let's move on to the next data set. Oh, this is a good one, because then I remember talking about this where maybe the criteria you're trying to work with is not existent, so you have to create another column. It's like, for example, like what if you're like, this one has beer, spirits, and wine, right? And you want to for each country, and then you want to know like, I want the ones that consume no beer, no wine, but a lot of spirit, something like that, Let's take a look at this. So I'm gonna skip this part because like we already know how to do that.
Yeah.
Let's just look at this now. What country has the highest number of wine servings, and what is the number? What countries consume no wine? Okay, let's answer this first one first. What country has the highest number of wine servings? How would you do that? If you were just to like look at this or not look at it.
So drinks is the data frame name. Equal square bracket drinks. And then let's see what country has the highest number. Inside the bracket, it'd be quotations and it'll be wine servings.
Okay.
And then close the bracket, do a dot count.
Yeah, okay. Well, actually, I could cover. Can I move this? Trying to like make this more. That's why I don't like the drawing thing here. Can I move this thing? Oh, I can move it. Okay, but I can't scroll down. I can. Let me see. Move it again. There you go. What was it? What did you say?
Yeah, it's drinks equal the data frame name drinks equals the bracket square bracket.
Okay.
And then you need to call out drinks. Okay, I just said square bracket of wine servings.
The reason why you do this, the drinks and drinks. Because you're gonna filter out drinks, right? But this drink, you're gonna filter it by looking at the wine servings column. So there's drinks, wine servings. This is just a column. This drinks bracket, you're gonna filter out the data frame. This is how you use it, because you're filtering out the data frame. Whatever you put inside the bracket filters it out, right? Does that make sense? Like that's what we've been doing for like every single time. Like, what if I wanted to do? You always start with drinks bracket, and I wanted to get like beer servings. So drinks, beer servings, and if you want it to be greater than 0, maybe greater than equal to, and then you close the bracket.
Okay.
But you always start with the database with a bracket, and whatever you put inside are all the criteria that you want it to fit.
Gotcha.
Okay.
Okay, so drinks, square bracket drinks, wine servings equal. Oh, double equal.
What was the question? Wine servings is the country that has the highest number of the wine servings is. Oh, that's just me answering it. What country has the highest number of wine servings?
Okay, so then equals drinks and then wine serving, or square bracket wine servings, dot max.
There we go. That's the reason why.
Because then you want to know what the highest is.
Yeah, and then the reason why you do this is your criteria. You want this to be true, right? You want to output the rows where where within the wine servings column you have the maximum number of wine servings. So maybe this is only one. This is how you filter one of them because it's max. There's only one maximum, unless if there's two, like of the same number. But the reason why you want to do this is like I want to output the column only or filter it to the point where the wine servings is maximum. So that's why you do this double thing. Because this part right here is going to give you the maximum wine servings, right? Number.
Okay, so that's why you do the double equal sign.
This one right here gives you the number of wine servings, right?
Okay.
This one gives you within the column, I want it to be max. And then once this is true, within each column that when it's max, that's the only thing I want to be outputted. That's why we have this outside drinks. Another way I could say it, let me just, yeah, that's the, let me output like where it says in the bottom here. So like, let's take out this guy. Drinks is not defined. Oh.
You got to run your data.
And let's put this guy. And then let's do that guy. There you go. So if you do that, so like if you look over here, this is what we want to get. What we want to get is just the row of the country that fit the criteria inside. Yeah?
Yeah, okay. That's why it says France is the number with 370 shown. Okay, that makes sense.
Yeah, but like let's like parse it out though, because I know sometimes this doesn't seem very easy to understand, but like whatever you put inside the bracket here is what you're filtering. This guy, right? This is the original guy. This is like
and we're just filtering down to the wine servings.
And then the question is saying the country, so it doesn't matter. The country is always going to pop up, but what is the highest number of wine servings? Highest number. So that's why you have, I want to have this where I want to filter this where the wine servings is the maximum, right? So this right side of the double equal sign is going to tell you what number to cut it by or to look for. It's going to look for 370 within like the wine servings column, right?
Yeah, because it's looking for the maximum number.
Yeah. So and then on the left side of the equal sign, it tells you where to look for this 370 in. Yeah?
Yeah, under the wine servings column, because you're calling out the wine servings column.
Yeah, and then obviously this is a Boolean, right?
Yeah, because it's going to be true or false if
So like everything is going to be false, and if it's false, it's not going to show up, right? It's not going to show up here. Because
if it's false, like if it has 0 or like NaN, then nothing will pop up in that column.
Nothing will pop up. And then like if so that's why you do this, because I mean it's just like a way of doing it in like using pandas. I mean there might be another way of doing it, but how you output it is you put it inside the data frame in the bracket, and whatever you put inside it is kind of like the comparison criteria, kind of like an if-else statement. If it's true, then it runs. But in this case, if it's true, it outputs. Kind of, it's similar.
Oh, gosh, okay.
If this is true, it outputs. If it's not true, it's not gonna show up, right? Nothing.
It's not gonna show up, yeah.
So it's like that. Okay, so this next one is the second question. What countries consume no wine?
Okay.
So how would you do that? Not looking at the answer. How would you do that?
So drinks, square bracket drinks equals wine serving, quotation wine serving, close the bracket, and it would have to equal 0.
Yeah. Okay. This is an easy one because
it's a double equal.
It has to be a double equal. Yeah. Do you know why, right?
Yeah, because we're calling it has to have the 0 in the column.
It has to be a Boolean. It has to be.
Yeah, it has to be a true. Yeah, it has to be true.
Yeah. you'll never see this as like just one equal sign. It's always whatever you put inside like these brackets has to be a Boolean. So it has to be greater than, equal to, greater than, less than, all the comparison operators. So this one, yeah, it's not that bad. So once you output it, and like you kind of confirm if you're right. So wine serving 0, 0, 0, 0, 0, 0. So that's all the countries.
Oh wow, how sad.
But yeah, that's an easy one. Let's take a look at another one. So now I want to get that's already existent, right? This column is in here, right?
Mm-hmm.
What if I wanted to combine these ones? And for example, I don't have a particular separate like column for it. It's like this guy. So what is the country has the highest beer and wine consumption? I don't have that here readily like available. So I need to create something of this nature. Like, so you know how to do this, right?
So drinks, square bracket drinks, and then do the beer servings plus wine servings.
Okay.
And that should give you your answer.
Yeah, it's not bad. This one isn't like a super hard one, because you're just creating a column, right?
Yeah.
And when you create a column, you just do like a new column with a data for a new column name equals the math to do that together, right? The two things you want to add. So yeah, that one, I think at that time when I was trying to like recall this, we were just trying to explain. But now I think this one is easier than this. I think in particular these are usually the harder ones when you filter things rather than creating a new column name. Okay, what about this next one? I don't know what I was trying to do with this one. So which country has the highest? This is the highest. Oh, the highest one. So now that we have that new column, how do we apply it? Kind of like what we did with the other one, right? Which country has the highest beer plus wine consumption? It's kind of like this maximum guy right here. Yeah.
Okay.
But this one, it was already here. Like we already know what the wine servings.
So we would take the math problem, the drinks, square bracket drinks, the beer servings plus the wine servings, close the bracket, and do a dot max parenthesis.
Yeah, it's exactly like this, but the only thing that's different is this guy.
Yeah, it needs to say beer servings or beer.
Beer servings plus wine servings, yeah. Okay.
Plus wine servings, yeah.
That's really what it is. But does that make sense though? Why you need to create it? Obviously, after you do that, you do the column name equal when it's max. I think that's the concept. Like, how do you get the maximum of like? How do you allow one thing to pop out of like a column? You have to get its column name, make it equal a maximum of that column name because that's the number, and then you filter it using this drinks bracket thing. Yeah, so those two things, I think we kind of concreted that. Like, here we know how to do it when it's already the column is already here available for us, and then here we know how to do it if we have to create a new column, adding two different columns or doing something with them.
Oh, and there's a new column that we created, the beers and wine serving column. Okay, I see.
Yeah, this by default when you do line 2, by default it adds it to the right. For the most part, it doesn't really matter where it is. You could put it in the middle. I think in the end, once you're publishing it, it makes sense where to add it. But like now, yeah, as long as it's inside, then you're good to go, or somewhere in the data frame.
Okay.
Okay. What about this one? Amount of countries that consume at least some beer. Which country consumes the least combined? I think this is it's not that hard, but what does that mean though? The least combined alcohol, beer plus wine plus spirit. The least combined.
So we want to. Oh wait, this is beer and wine.
It's like a different one, yeah. It's like everything pretty much.
Okay, so you would put the drinks and then the square brackets and then call out the 3 column names. So like beer, comma, spirit, comma, wine, and then do a greater to or equal to 0, or no, less than or equal to 0.
Like when you're saying the least combined, that's like beer is greater than 0. Yeah.
Okay, so it's greater than. Okay, so greater than or equal to 0.
Yeah, greater than, not equal to, because you want it to have at least 1.
Oh, okay. So then just greater than 0.
Yeah, greater than 0, because 0 would mean they're not consuming. So yeah, that's and then the question here is kind of similar. So after you create the new column, you know how to do that already. It's this guy, line number 5, and then like line number 6. Line number 6 is very similar. Which kind consumes the least? So not the max, right? It's the least.
Dot
right?
min.
Yeah. So dot min is the same thing as what you did after you create the new column. You put that inside the brackets of the data frame that you have originally, and then like you make it equal the statistic, which is the mean in this case. So simple, right?
Yeah.
The one thing is here is that you cannot have the 0 in there, because then like it would all be there would be a lot of them. it would be the mean.
Oh, okay.
Or it would be the minimum. It would be the minimum. You wanted like the one that that actually at least drank, but the minimum that drank.
Yeah.
Yeah. This says the countries that at least had some beer. So that's it. I think let me see the other ones. Are there countries that consume some spirit, some wine, and no beer? If so, which countries? Some. What does that mean? Some. I guess they put like a hint here, non-zero. So some meaning like at least, kind of similar, right?
Mm-hmm.
Some would be at least, so it can't be not 0. So this is just doing like a stacked lock, right? A stacked lock criteria.
Okay.
You're right. Like you look at this: consume some spirit, and some wine, and no beer. There's 3 criteria, right?
Okay, so inside the bracket, it's the spirit would equal 0. The beer would the wine would equal no. The spirit and wine would be greater than 0, and then the beer would equal to 0.
Equal, right?
Equal 0, because it has to be a 0. It's a Boolean, and it has to be true for it to be 0. So it needs to be double equal for 0.
Yep. Yeah. So that's what I have here. I wanted to start with the beer because like.
Okay. I went backwards.
It doesn't matter. Like it would be the same.
Okay.
I just wanted to follow like the column thing. So I knew ahead of time it's gonna be a lot. The reason why is because you have multiple criteria, right?
Mm-hmm. Because you're calling out multiple labels or columns. Yeah.
And usually that you default to a lock for that. So when you do that, you have a lock criteria 1, and lock criteria 2, and lock criteria 3. Easy. Now you can see like, oh, okay, that's how it gets used.
Okay. I called it. My order, but the order I called out is fine though, right?
Yeah, it doesn't matter. It doesn't matter what the order is.
Okay.
As long as it's inside the bracket, the square bracket. As long as it's in there. The way I usually, like if you were writing this so that it's easier to read, put them inside like a parentheses, like for each one. So they're like group, and then ampersand it, and then another one, and ampersand, and then this guy.
Gotcha. Okay.
And that's it. Like, I think like with all those multiple ones, you can now see like, okay, the output, and I always know what the output is. So a lock, when do you use a lock? You use a lock when there's like multiple things you want to filter out, right?
Mm-hmm.
And then what's the output of a lock? So like once you apply a lock, it filters it to the criteria when it's true, right? When this is inside,
whatever you're calling out inside the lock, it calls out the true criteria.
Yeah, but it's applied when there's multiple ones. If you don't need multiple ones, you can just do the typical slice that we've done like here, where you put it inside. You have a data frame. You put like the square bracket, and then you put one criteria, which is like this min, max, whichever one. If there was like another one where you wanted it to be min in 2 cases, you would do a lock. Like, for example, you wanted to have a minimum in right? If you have more than one criteria, you do a lock. If you only have one or single criteria, you don't need to do a lock.
We don't need to do lock. Only if we have multiple criteria.
Yeah. Like because it would be pointless. Like, I mean, you could do it like in an easy way where you don't have to apply the function, or you could just do a slice. This is, the typical way of doing this. You could do what a lock does, but for now, yeah, just think about it that way. A lock does it when there's multiple criteria, and if it's single, you can just do a slice of a data frame like this. All right.
Okay.
Let's actually try to do some NumPy.
Yeah. So what is NumPy? That's where it calls out an array of numbers, right?
Yeah. So like it's pretty much the same as a data frame, but the thing is it's numbers. It's just numbers.
Oh.
Yeah. So NumPy is just a data frame, a bunch of rows and columns, but then it's just instead of rows and columns of words and numbers combined, it's just rows and columns of numbers. That's what a NumPy is. So like let's try look at what this is. I'll try to explain. It's like a lot of this is like very I mean there's a bunch of math because it's numbers. So generate an integer random NumPy A shape 5 by 5 with elements from 1 to 5, including 1 and 5. Print the generated random array. Okay, good, whatever. So I guess we're given the variable here, right?
Okay.
This A guy. So once we have that, we just plot that guy here.
A equals NP for NumPy because you import NP as NumPy.
Yeah, and then the functions you want, because we gotta read this. So it says here it's an integer random. Integer random.
Oh, okay. So dot random.
Yeah, so that random, it gives you the random part. Go figure it. And then dot rand int gives you a random integer, because it needs to be a random integer, right?
Oh, okay. Random and integer. Got it. That's what it means.
Yeah. So random dot random integer, and then like whatever you put inside here is. So what does it say? What are we allowed to output? So
5 and 5. So from 1 to 5.
Okay. So this first argument, the 6, it's saying including 1 and 5, right?
Mm-hmm.
When you put in 5 here,
it'll only go up to 4.
4, yeah. It's the same as anything in the world of Python. It doesn't include the last thing.
No, because you start with 0, so it would go to 4. But if you want 5, you need to go 0. You need to put 6 because then you'll get 0 to 5.
Exactly. Yep. And then the second argument is the size of it. They give it to you here, the shape, 5 by 5.
Oh, okay. So okay.
It doesn't have to be worded this way, but you can always if someone were to ask, what the heck does shape mean? You can always oh, that's the size. Okay. I don't know why they deliberately asked you to do this. Shape 5 by 5. It looks like a coordinate.
Yeah.
Yeah. I think that they're trying to give a hint by doing this, but in essence, it didn't really communicate well. I think I was a little bit confused when I was looking. It's like, oh, that's what you meant by that. So 6 size, and let me explain the output. So you get this guy, right?
Mm-hmm.
So you should say it's all random. Every time I run it, it's gonna be random.
Yeah, it's gonna be random numbers popping up.
Yeah. So you see this double bracket thing? You've seen this before, right? The double bracket. And that's what we've used before for a data frame, but now it's just numbers. This right here is the first row, right?
Mm-hmm.
Because it's a matrix, right? In essence, a data frame. This is a data frame of numbers. So this is the first row, kind of like this guy, kind of like the first row right here, or like a bunch of rows, right?
Yeah.
Like each one of the rows of a data frame in Pandas is associated with each one of the rows of a NumPy. It's pretty much the same, but it's just a bunch of numbers.
Yeah, so each row, there's 5 rows and 5 columns because that was the size we're calling out for, right?
Yeah, and then the columns is through here. I usually just read this by rows, but you have the row 1, row 2, 3, 4, and 5.
Gotcha.
Does that make sense? That one's like how to create.
Yeah.
Okay, let's try actually do something with it. And then so this one, transpose. It wants you to do the transpose. There's a bunch of theoretical things there. I'll just explain it. So when it wants you to do transpose of A, what it wants you to do is just flip it. Like all the row numbers now become columns. So take a look at this. So when I print this guy out, and then let's try compare this with this. So you see the column is 25405, right? For this first column.
Oh, okay.
Now it becomes a row.
It becomes a row. Okay, and then the 1, 3, 4, 3,
exactly,
1.
Yeah.
Second column is the second row.
That's what a transpose is. So that's good, yeah. So that's what it's wanting you to do. If ever someone were to ask you print the transpose of your data frame, you could have done this. You could have done a transpose of this data frame right here. It's the same thing. This is exactly a NumPy with words.
Mm-hmm.
And a NumPy is just it's a data frame, a Pandas data frame with just numbers. It's the same thing. And then when do you ever use a transpose of something like this? For example, you know, when you've probably seen it, but you have like so many columns, like column names. There's so many that it's off the page, right?
Yeah. That's my data frame in my project. Yeah, there's like 36 columns.
Exactly. But then, for example, what if you want to print the summary, and the summary just has like 5 entries or 10 entries, right? Versus like 100 columns that you may have. If you took the transpose of that, it's easier to read. It doesn't go off the page.
Oh, I see what you're saying.
Because it flips it. Whatever is longer is this way now, and then the shorter one is this way. That won't go off the page. That's like one application. I think maybe there's more, but I think that's one. So this one, let's print the first 3 rows of A. We've seen this before. This notation.
Yeah.
So I'm just gonna print it. So now if you look at it, like so this guy right here.
Yeah. So we just print the first 3 rows.
Yeah, 1, 2, 3, right? Because of this 0 to 3, not including 2. So 0, 1, 2. And then this guy meant like, what does this guy mean on the right? All the what? All the columns, yeah?
Yes.
And then this one is the rows.
Just the rows.
Yeah.
Yeah.
Rows on the left, columns on the right.
Columns on the right. Okay.
Yeah. Same with this first 3 columns.
So then that's the colon and then 0 to 3.
Yeah.
We
very
just
much
like
similar.
We transposed.
There you go. No, I'm liking this word transpose. Yeah, you'll see it like I guess you won't see like obviously when someone talks, it's like what the hell why are you saying transpose?
Yeah.
but it's just a terminology. The switch columns and rows. And then let's see this one. Broadcasting. They sometimes use this term broadcasting. Has your professor talked about broadcasting?
I don't recall.
Okay. So broadcasting is just another term like transpose, where you're gonna add, like for example, you have B right here, right? This is one row, right? And then you have A. You define A as this guy. You broadcast it in terms of broadcasting is you only define one row, but you're adding it to all your rows. You're broadcasting one row to all the rows. So like you're adding it to all the rows. So like this 1, 2, 3, 4, 5 is being added. Even though it's only one row, you're adding it to all the rows.
Oh, okay. So we're adding one.
For each one, like you look at each row, you just add 1 for the first element, 2 to the second,
third.
Yeah.
Okay.
And that's what it means. Broadcasting is just adding everything, like one column for all the rows, or one row for all the rows, and then one column for all the columns. So this is for the rows. You could also broadcast with columns. The broadcasting with columns is a little bit complicated, but all you have to do is this reshape thing. So when you do a reshape, what ends up happening is, you know how like this is a row right now, right? And I want to flip it. I want to transpose it. I want to make it into a column, right?
Okay.
So another way of doing that is reshaping. So you know how you take a look at this guy. When you look at the reshape, usually what you call for the first is the row, like the number of rows that you have. Same with this guy, right? Same with this guy, right? On the left of the comma is the row.
Yeah.
The right of the comma is
the columns. Yeah.
Same with anything else. So with the reshape, left of the comma is the row, right of the comma is the column. So this one right now, the shape of this is going to be 1 by 5. Yeah, there's 1 row, 5 columns, right? I want to make this into 5 rows, 1 column. The reason why I want to do that is I want to broadcast it to all the columns. So
5 rows.
So in order to broadcast a row to all the columns, I have to make it a column first, right? I have to make the B a column, not a row. So that's why I'm reshaping it. I'm reshaping, instead of a 1 by 5, I'm making it into a 5 by 1.
Okay. I think I'm kind of following it. It's a bit confusing, but I think I
Okay, let me actually, because I kind of combined the steps on this guy. So let me just do like, it's always better to see like them in steps. So 5, 1. Here, this is actually just reshaping it and making it into a column. So that's what happened, right? I made it into a column.
Yes.
Yeah. I mean, yeah, don't get deterred by like how it looks.
No. But B is a column now.
Yeah. So yeah, this B is a column, and then what are we trying to do? We're broadcasting it, right? So A was whatever it was.
It was 5 rows, 5 columns. Yeah, 5 by 5. Okay.
So now that we have a column, I'm broadcasting a column now because B got converted into a column. So now you just have to add it. And then in terms of broadcasting, by terminology, that means you define one column, one row, and you add it to all the columns or rows. And that's what ends up happening. Let's see what happened. So I forgot what A was. I guess let's try. I guess we can print what A is. So print A. So this is A. Let's see what happens. So 25405, right?
Yeah.
To confirm. And then one plus 2. I guess it's 2 plus 5 is 7. 3 plus 4. Yeah.
4,
so that's
7. Yeah. Okay.
And that's it. And that all of this is just basic stuff for NumPy. There's actually more things. But let's see. Let's talk. We can probably talk about this next time though.
Okay.
Because I wanted to go like obviously last time like when we're talking about it, I wanted to like kind of like review it and then like add more things to it. But again, for next time, let's talk about like actually applying. I'll show you what this is first. So here the statistics are here, and then we're probably applying it to something with like more meat to it. And then like this guy, I'll talk about each one of these. And then the other thing is, once you know how to do all of that, is what if you wanted to do like this part, data visualization. This is a good one. So data visualization. So the histogram, you know how to do this one, right? And then I think I did more in this guy. So this is using Matplotlib. And then now I want to use, is it still, yeah. So there's actually a way to plot with Pandas, not with Matplotlib. There's a built-in plot function in Matplotlib, Pandas. So I mean, it's very similar. And another one would be maybe, creating this guy. Where's the Seaborn guy? Here's Seaborn. So
yeah, Seaborn. Okay.
So using Seaborn, this is how you do that. Like you can combine things like more flexibility to the user. Like you have a histogram, you have a density function, and you combine them. So and there's even another one I will show you where like, I mean, right now you're probably like, why do you like? So this is Matplotlib, right?
Yeah, that's one I know.
And this is Seaborn right here.
Okay.
What's the difference? Why does it matter?
Yeah.
And then here's another scatter plot from Matplotlib. Here's Seaborn.
Okay.
If you look closely, there's a difference, right? Like this is like more defined in essence. And then not only that, but we'll go over this again. But like, look at this guy right here, Matplotlib, and then look at this guy. There's a difference, right?
Yeah, you're just on the Seaborn. You're just calling out the x equals what to label it and what the y equals. The other one is you have to x equals the data frame. Yeah.
So in essence, this one actually takes a longer time because then you have to look into the data frame, load in the data frame, the column. Here, I'm just passing it like the names, and then the names of it, and then the data right here will kind of take care of like all of this, all the x's, all the y's are all within this data frame. Here it's like, okay, let me go to the data frame, let me look for the evaporation column, and then for a while, let me go look at the data frame, and then let me look at the temp 9 a.m. column. And then not only that, so syntax-wise is different. It looks different. I think for me, I guess it's just me. This looks better.
No, that one does look better. And I'm wondering now, like when I did my Matplotlib homework, if I was like combining Seaborn unintentionally, not knowing, and Matplotlib.
It's always good to test the waters and kind of like, oh, you know what, this one. This is hard for me to know. Like, what if I were to pinpoint something? It's a blob that's like,
Yeah, it's a blob, but
coloring. Versus this, like someone really like intricately pinpointed it,
Yeah. Okay. I'm like convinced that that's what I did on my Matplotlib homework.
That's good. And then like we'll talk about this Reg Plot. This is the one I was talking about. You know how when you have like the correlation.
The correlation. Yep. The linear regression.
So temp and then evaporation. Those are just two categories. I want to see the correlation. So that correlation gives you the slope of this guy. So whatever the slope is, positive, it's a positive number. It's increasing, and it gives you to correlate that to the heat maps. So here's a bunch of stuff you already know. That's the line graph, box and whisker. This is another one which is really nice. And here's another one you probably haven't seen, Violin Plot.
No, what is that?
I know.
That's pretty cool looking.
For the first time when I was like, when I saw it, I was like, is this really true? Is someone making a joke? Violin Plot? I was like, what is it? Like, is it scientific? Violin Plot?
But it's cool looking.
Yeah, it looks way better. It's pretty much the same thing as this guy. But I think I'd rather default to this because it's unique, right?
Yeah, it's pretty unique.
If you were to show it, like change all your box and whiskers to Violin Plot, I think it'll be nice. Someone will comment on it.
Yeah.
and then this other one is a heat map. So yeah, this is actually what I wanted to refer to. So to correlate the regression graph to like a correlation dot core and then to a heat map. All of them are pretty much the same. They're telling you the same story. So if you look at this, it's the same as a correlation, right? Kind of. And it says correlation here. And this gives you like a heat map or like kind of like different types of ranges of color. And you know, depending on like the magnitude, it's dark, and if it's low, then it's lighter. And if I were to show this, you know, the correlation dot core function, it gives you numbers, right? So you can actually do that as well. So numbers and colors. So one. Yeah, and this is nicer. It's more attractive to an audience if you were to present it versus the numbers only.
Yeah.
Yeah. And yeah, that's like a bunch. And with Seaborn, you can do this. What I did here, you can pair plot them.
Oh, nice.
What if you wanted to like present? Because sometimes, you know, multiple slides. If you don't see the same graph in the same slide, it's harder to compare. But if you see them in the same, then okay, I see the correlation. And then you can do it with these as well.
Oh, these are pretty cool.
Yeah. So
now it's just to understand them.
Yeah, I mean, using them, we'll talk about it next time. I wanted to really like take our time with the data, like the pandas.
Yeah.
Pandas is like the, you know, part one of like data science, and part two is like visualizing it. So yeah, for this, yeah, and we'll even talk about like the other part. You know, with Numpy, it's not just like the number. There's like applications for it. So we'll kind of do the same thing. Answer some questions how you can convert words into like a data frame. And then we didn't really touch on the. So are you guys done with Python after this week?
Yeah.
Okay. Man, there's like so much more you can.
No, I do want to go over more. I do, because it seems like because you know, even though I'm quote unquote not job hunting at the moment.
Okay.
I do on occasion when like I'm sitting in my daughter's class and I'm bored.
Yeah.
You know, I'll start. I'll go on like LinkedIn or Indeed, and I'll just kind of browse, and a lot of them are calling for Python.
Yeah, you're right. Yeah, that's what I was saying. Like Python is the main skill of the, you know. Of the era.
So I'm just looking at what the job requirements are. It seems like a lot of Python, so it's like, okay, I need to focus and get my energy into the Python and
Pythonic way. There's let's actually like continue doing Python. Like after this one, you know, like we'll talk about JSON obviously. And then like maybe we'll talk about like machine learning. What other stuff? What other parts have you seen in the requirements? I guess like for Python. Like, what is it about Python that they want you to be proficient in?
You know, I didn't get that far. I just saw Python. I'm like, okay, Python. But
okay. But like I would think like it's that like all this is the same. Like, you know, it's probably the same across the board with anyone. Like you have to be proficient in like Matplotlib, data frame, pandas, whatever. And then all the basic stuff, and then like maybe machine learning. I don't know if machine learning is like the other part. Like part one is data science, and then part two is now that you know how to work with existing data, can you guys can you apply like predictions? It's like predicting things.
Oh, okay, I see what you mean. Yeah.
Yeah, it's really what it is. It's like using the existing data, and now I want to see what the future data is. So future data, you really have to like look at the existing data, do some probability. But if we get to it, if we don't, if not, we can just talk about SQL and then Java.
Okay. Yeah, I'll let you.
Because those ones, I would say it's not really used much. SQL, and you do SQL in like Python. You can do Java and Python.
Oh, really? Okay.
Yeah. Oh, yeah. I wanted to ask them. Do you know what you guys will be like what program are you guys using for Java or SQL, like IDE wise?
I don't know. And in fact, when I tried to do the download that we were doing in class, my computer actually shut down on me.
Oh,
So
okay.
I didn't get to do a download at all. But
Okay.
it is in the GitLab. The information's in the
Oh
GitLab.
yeah. I'll look at it. Yeah.
Yeah, just
I forgot
go
about
use go use my login and take a look. It'll tell you what it is.
Okay, I'll take a look at it, and then it's gonna be. I mean, we're kind of like taking our time, but I think it's good.
Yeah.
Because like I
Well,
want
no,
you.
I want to take my time.
Yeah, if you guys do have homework though, like coming up for SQL, let's like talk about that as well. If you need help,
Okay.
you can show me that. And I think that's it. I'm sorry we went overtime, but
That's
good
okay.
luck on your project presentation.
Yeah, I'll let you know how that goes.
Yeah,
And then
I guess we can meet again. You said not Monday, but like because we already did one today, but you want to do it Thursday
yeah, that's fine.
and then Monday next week. So we'll do the Monday
Yeah.
Thursday like
Yeah.
sequence. Okay, cool.
Okay, cool.
All right,
Thank
good luck
you, Paul.
and let me know.
Okay, thank you.
All right,
Have a good night. Bye.